Hi, my name is Ishika. Today I will explain the assignment 2 where I used decision tree classifiers to predict outcomes for two different scenarios. The first part focuses on tennis playability based on weather conditions, and the second predicts the likelihood of having COVID-19 based on specific symptoms. So now this is the part A. In part A, I have set up the decision tree model to predict whether it's suitable to play tennis based on the environmental factors. The dataset I created has the three main features: temperature, weather, and wind, and the target variable or the label is encoded to indicate if playing tennis is recommended or not under each condition. After generating this dataset, I applied label encoder to transform the label values into numerical data as a machine learning models require. Then I combined the temperature, weather, and wind values into a future matrix and use the label as our target output. Now with the dataset ready, I split it into a 80-20 ratio, reserving 80% for training and 20% for the testing. Then I trained the decision tree classifier on the training data. Now this model learns the relationship between weather condition and the playability of tennis. Then I demonstrated the model's predictive capabilities using some sample conditions such as 21 degrees sunny and windy. Now the model outputs whether it's suitable to play or not by predicting either yes or no. Then finally, when I run this code, it prints the prediction result to see how well the model generalized based on its training. Now in part B, I applied a similar decision tree setup to predict COVID-19 likelihood based on the symptoms. The dataset includes three key features related to COVID symptoms: fever, cough, and sore throat. Now, each of these features is binary with yes or no values. One challenge here was balancing the data. If one outcome, such as no COVID, appears more frequently than the other, the model might be biased. Now, to address this, I ensured that each class had a similar number of samples using techniques like duplication of minority samples where necessary. Now, this balancing steps improves model reliability and prevents it from overly favoring the majority class. Then I split the data with the 70% for training and 30% for testing. Then I trained a new decision tree classifier to predict COVID likelihood based on these symptoms. And when I run this code, it gives me the accuracy of the COVID-19 model, that is 100%. This is my CSV data for COVID prediction that I have created. So in conclusion, this decision tree models provided predictions for two distinct scenarios by analyzing relevant features, while Part A focused on the recreational decision making based on the environmental conditions, and Part B used medical symptoms data to assess COVID-19 presence. So this project highlights how decision trees can be adapted for various types of prediction tasks, and with more features or data, they can provide even higher accuracy. Thank you.